Hello, this is John from caveofprogramming.com. In this tutorial we're going to take a look at the set STL class in C++. A set only stores unique elements, so if you can use insert to insert elements, and if you try to use it again with an element that has the same value, then it just won't insert it. So I'm going to give you an exercise at the start of this video because if you understand just what a set is, it's something that only stores unique elements and it orders them as well. And if you've absorbed the material from the previous videos, you should be able to figure all of this out for yourself. So I'd suggest stopping this video and trying to add values to a set. Start with a primitive value like int or double or even string, which is not primitive, but you could try strings. And then try adding objects to a set of a class that you defined yourself. And that works similarly to what we saw with map. We saw custom maps or custom objects as map keys. So you can try that, and you should be able to do it if you've got a good grasp of the material we've seen so far. So what I'm going to do now is I'm going to go on to show you how to actually do that stuff. So if you had a go at it and it worked, then congratulations. And if not, then don't feel bad, because of course it is difficult, even if you type out the code, to fully get your head around all this without quite a bit of practice. So let's take a look at it. So I'm going to add some numbers to a set here. We have to use the insert method to add them. I'm going to deliberately mix up the order here. Let's have 4 of these. Let's say 10 and 30 and 20. We can iterate through the set using the same syntax that we saw through a vector. That we saw for a vector. So I need to use the set type and get an iterator from that. Let's call it it. Set it equal initially to numbers.begin, and you probably know the drill by now. We're going to keep going as long as that's not equal to numbers.end, and we're going to use the overloaded ++ operator to increment that iterator, and we're just going to output the thing referred to by that iterator. Looks like a pointer dereference, but it's actually an overloaded star operator. So if we run this, we get the values in the set. If I try to add the same value twice, for example, we can add 30 twice, then the second method call just doesn't do anything. You can see the set storing the values in order of the values that I've inserted, with the smallest first. And it's keeping a unique set of values. So we only have values in there that are unique. And that means that sets are really good for if you've got a load of different objects. Some of them are duplicates. It's really good for getting rid of the duplicates and finding only the unique objects in your list there. If we want to know if an object is on a list, is in a set, we can use the find method, as we saw, for example, with maps. So we can say, let's say, set numbers iterator. Well, actually, let's copy this one, and I'll call this it find equals numbers.find, and we want to type in there the element that we want to find. So we want to see if 30 is in the set. Then we can say if it find is not equal to numbers.end. So as long as it hasn't searched through the entire set and gone off the end of it without finding it, then we can say cout found, and we can use the kind of dereference operator on this iterator, just like with a vector, to output that element. We've got a warning there, but it's maybe just the usual end line bug. No, it isn't. I need to use it find here. Let's try that. I think that will work. Let's build it and run this, and we see that we've found 30 in there. But if I put something in here that wasn't in the set, like 130, then of course that if isn't going to do anything, and we could put an else on there to say not found. There's a simpler way to check if an element is in a set, which is we can say if numbers.count 30. Well, we could just leave it at that, actually. And if we find it, we can say cout number found. So count, because the elements are unique in a set, count is only going to return either 0 or 1. So it's kind of strangely named, really. because it's not really doing a count. It's just saying, is there one of those elements in there or isn't there? This is only going to return 0 or 1. And remember that 0 is equivalent to false in C++ and 1 is equivalent to true. So we can say if found, if numbers.count, in other words, if numbers.count is equal to 1, in other words, if it's true, it returns true, then we can say the number's not found. If it returns 0, that's equivalent to false, and then we could put an else in there if we wanted. You can also use objects of your own classes in a set, and that works the same as using your own objects as the values in a map. So if this is getting a bit repetitive now for you, you can skip the rest of this video, but I'll go over that again here, just the same as for a map, just so that you can see it working. So let's say here we've got a class called test, and test could have maybe an int ID, and let's give it a string name. And let's give it a public constructor, test, which takes the int ID and string name and uses it to initialize the actual instance variables there, like this, so we can use the constructor initialization list. We don't have to provide any more implementation. And let's give it a print method as well. Let's say void print, and we're going to look at a more elegant way of doing this later on in videos on operator overloading. But for now, we'll just give it a print method. So let's say endler, and I also want to put the name in there. So we can add test objects to a set quite happily. Let's maybe just maximize this. So let's create a set here. This isn't going to work to start with, but what I want to show you is I want to show you what errors come up and how we have to fix those. So let's say set of test, and we'll call this tests. And then let's just add some values to that. Let's say tests.insert, and we'll say test, and let's give this a ID. So let's say 10 and Mike, like that. And let's add maybe 2 more of these. So let's have 30 and 20 and Joe and Sue. And we can iterate through that and output all the elements one by one using an iterator. So I'll just copy this previous one. Now it's going to be tests.begin, tests.end. And instead of we can't do cout on our objects here because we haven't overloaded the put2 operator. We'll look at that later. But what we can do is we can say it arrow print to get the information there from this object. And of course, this needs to be a set of test, type of the iterator. Now, if I build that, it's not going to work. I don't think I made any mistakes here, as far as I can see. Let's just see what this says. Candidates of void print. I think it's probably okay. So I find it hard to be sure till I compile the things, but this is probably all right. But let's try to compile it and see what happens. So I'm going to go to build project, and we'll get a whole slew of errors here. Let's see what we've got. So as always, we scroll right to the top of the error message, and we say it says print not viable. This argument has type const test, but function is not marked const. So the reason it's complaining here is because this iterator returns a const test object, in other words, one that can't be modified, but it doesn't know whether the print method modifies the object or not. So it won't let you actually do that. And to allow us to actually call print, we have to tell C++ that, yeah, print is const, it doesn't modify the object. Therefore, we can call it on this const object returned by the iterator. So what we have to do there is just put const after the declaration of print, and this means that in the body of print, it's definitely not going to change any of the instance variables. So let's build this again. So again, it's not going to run yet, but we'll see what comes up. Now, if we look at the error that comes up now, we've got, let's see, we're getting the error that says error invalid operands to binary expression, const test and const test, and it's you can see here that actually internally set is trying to do a comparison with the less than operator on our objects, and since that operator has no meaning for our test object, it can't actually do that. So we need to overload the less than operator, and again we'll go into more details about this in the section on overloading, but the way it looks is like this. The less than operator has to return a bool to say yes, this object is less than the one we're comparing it to, or it isn't. And we're going to overload operator less than, and that accepts another object to compare with this one. We make it const because we don't want the less than operator to change the object that it's comparing, and we use a reference because we don't want to have to copy the object when we pass it into less than. We just want a reference to an existing object. And the whole operator is also const, meaning it doesn't modify the object that it's being called on either. Let's implement that, and let's say that we consider tests to be unique if they have a unique name. We'll just ignore ID for the moment for simplicity, but you can see in the lecture on using custom objects as keys in maps how to take both of these into account. But let's just say that two objects are the same as far as we're concerned if they have the same name, and we can use name to compare them alphabetically. So we can just do return name less than I have to put the type in there, other. So this, sorry, not the type, I have to put the name of the object that we're passing in. I have to give it a name. Let's say other dot name. So it looks just like a function declaration, except it's got the keyword operator and then the operator that we're implementing. So this has a little syntax error, so probably I've done something wrong, but I don't really see what. Yeah, I've got the reference thing in the wrong place now. Sorry, bear with me. Hard to program and talk at the same time, and even when I'm programming without talking, I make a lot of mistakes, which the compiler fortunately catches, I must admit, unless you think about everything really, really carefully. Very hard not to make mistakes, but this is right now. So we're passing in a const test. Well, let's read it backwards. A reference to a test that is constant. It's a const method, returns a bool. It's the operator less than, and we're returning the results of comparing strings, because this less than operator is implemented for strings, and it will compare these two for us, returning true if this is less than this, false otherwise. So that's what we want. Now, I think this is still not going to work. Let's build it and see what happens now. In fact, it does work, which I'm a little bit surprised by, because I thought we were going to have to, earlier on when I tried this, in fact, I had to implement a default constructor, but I guess that's because I don't know why, maybe I did something different, but you should implement a default constructor as well, because there may be some situations where you need that. Let's set ID to 0, and let's set name equal to an empty string. And you're also kind of probably going to implicitly end up using the equals operator, but the assignment operator, but C++ provides a default implementation of that hidden away behind the scenes that will do a shallow copy. It will just copy the values of variables from one object to another, as we've seen previously. So anyway, this works. In fact, let's just get rid of this for a second and see if we can really run it. I'm a bit skeptical. So it does actually work, which surprises me. And as I said, it didn't work when I tried it earlier, but I don't know what I did different. And you should provide this anyway, because it's a good practice. So now we can see that we've successfully stored the objects in our set, and it's only going to store unique objects in there. So let's insert another Joe. Now, when is an object unique? That's defined by our less than operator here, and our less than operator is only comparing the name, so we can happily give Joe another number. Let's give him something quite distinct, like 333. But because this Joe is the same as this one, because as we've defined the less than operator, it has the same name, so it's identical. We're not going to be able to do the second insert. If we run this here, we see that the elements in the set are exactly what they were originally. We haven't inserted this second Joe, and that behaves exactly the same as the keys in a map, which, as we've seen, if you try to insert a key value pair in a map and the key matches a key that's already there, the insert doesn't happen. Map just changes the value, and in the case of a set, the insert just won't happen, and that's all there is to it. Okay, so that's it for this tutorial. Until next time, happy coding.